Here I'm going to discuss the SN1 mechanism, substitution nucleophilic of the first order, and I'm going to do it on a very generic molecule. So we can see here that we have a tertiary molecule in which the leaving group is on a tertiary carbon atom. It's necessary for it to be tertiary because during the course of the mechanism we're going to be generating a carbocation. Carbocations are stabilized through the inductive effect and hyperconjugation by having more neighbors. So tertiary undergoes the SN1 mechanism more easily than a primary or a secondary. So in the first step of the generic SN1 mechanism, the leaving group leaves. And what is formed is that carbocation plus the leaving group. In this, I'm drawing it as a negative charge. It could obviously be neutral, depending on the course of the reaction. The formation of this carbocation is the rate-determining step. It is the slow step, and we'll see how that impacts the reaction diagram in a little bit. We have the carbocation in the leaving group. Now, with the carbocation free, the carbocation can react with any nucleophile that is present. So a nucleophile is one that has lone pairs of electrons that can form a carbon bond. So the nucleophile that's present in the reaction attacks the carbocation. After the nucleophile attacks the carbocation, we're left with a product that now has the nucleophile substituted in for where the leaving group was. The rate determining step is unimolecular, so that is why it is a first order reaction, because only this compound appears in the rate law, so it is substitution nucleophilic of the first order. The reaction diagram looks like this. We have our reactants, and that's just the compound that contains the leaving group. We have our products. That's the compound that has the nucleophile substituted in. We also have the carbocation intermediate. So the reaction diagram looks like this. The top of the hills are the transition states. Bonds are made and broken in the transition state. So in our first transition state, what happens is the bond between the carbon and the leaving group is breaking. That's what is going on in the first transition state. And after the bond is broken, you have the carbocation intermediate. In the second transition state, you have the bond between the carbocation and the nucleophile forming. And then after the bond is fully formed, that's when you get the nucleophile attached to the carbon atom in the product.